Let's talk about linear function, which is fundamental in both basic algebra and data analysis. So a linear function is typically expressed in this form: y equals a sub 1 times x sub 1 plus a sub 2 times x sub 2 plus ellipsis plus a sub n times x sub n plus b. So in here, y is the output of the function. X sub 1, x sub 2, ellipsis, x sub n are the features or variables. A sub 1, a sub 2, ellipsis, a sub n are the coefficients of the variables, which represent in the scalars multiplied by the features. So b is the constant term or y-intercept of this function. So this function is a linear because each term involves only the first power of each feature, and these features are combined through additions and subtraction. First, let's talk about single variable linear function, y equals ax plus b. So it only has one feature, which is x. Let's say y equals 2x plus 1. So this graph will be a straight line in two-dimensional space because it only has one variable. So it is one-dimensional linear function, which demonstrating how the output y linearly depends on the input x, and the slope is 2 and the y-intercept is 1. So here is a two-variable linear function, z equals ax plus by plus c. It has two features, a and b. So for a two-variable linear function, let's say we have z equals 2x plus 3y plus 1. So this is a plane in a three-dimensional space. And this two-dimensional linear function, z equals 2x plus 3y plus 1, is a plane in a three-dimensional space. So this plane orientation is determined by the coefficients 2 and 3, which is associated with x and y respectively, and it intersects with the z-axis at 1. Let's talk about a function that depends linearly on three features. X sub 1, x sub 2, and x sub 3 can be written as f of x sub 1, x sub 2, x sub 3 equals omega sub 0 plus omega sub 1 times x sub 1 plus omega sub 2 times x sub 2 plus omega sub 3 times x sub 3, where the parameters omega sub 0, omega sub 1, omega sub 2, and omega sub 3 are the scalar numbers, and the weights omega sub 1, omega sub 2, and omega sub 3 linearly combine the features, and then we add in the base term omega sub 0 so that we can produce the outcome of f of x sub 1, x sub 2, x sub 3. So in other words, this outcome is produced as a result of linear interaction between the features x sub 1, x sub 2, and x sub 3, and plus bias. Let's say we have an example function here, f of x sub 1, x sub 2, x sub 3 equals 1 plus 2 x sub 1 plus 3 x sub 2 plus 4 x sub 3. So here, omega sub 1 is 2, which is the coefficient of x sub 1, which suggests that x sub 1 has a moderate impact on this outcome, which increasing the function's value by 2 times whatever x sub 1 it is. And omega sub 2 is 3, which is the coefficient of x sub 2, which indicates that it has a stronger influence on the outcome than the x sub 1, which increasing the function value by 3 times the value of x sub 2. And omega sub 3 is 4, which is the coefficient of x sub 3, which suggests that it has the strongest impact on the output among these three features, which adding 4 times the value of x sub 3 to the outcome. So let's try to visualize it. We have three features plus one output, which means it is four-dimensional function, which is challenging to directly visualize it, but we can plot several slices of this function just by fixing one variable at a specific value and varying the others so that we can see how the function behaves, right? So let's plot it into two scenarios. So first scenario, we vary x sub 1 and x sub 2, well, keeping the x sub 3 is 0. And the second scenario, we vary x sub 1 and x sub 3, while keeping the x sub 2 as a 0. So in the first scenario, this surface illustrates the combined linear effects of x sub 1 and x sub 2 on this function, and the slope along the x sub 1 axis is gentler than along the x sub 2 axis, which reflecting the coefficients 2 and 3 respectively. And in the second scenario, the effect of x sub 3 is more pronounced due to it has a higher coefficient, which is 4, which creating a steeper slope in the x sub 3 direction when it compared with the x sub 1 direction, right? So these plots demonstrate how each feature linearly influences the outcome of the function, and the best term shifts the entire plane up by 1 unit in the outcome space.